Welcome to section 2.3. In this section, we're going to talk about the second rule that we can use to help us solve equations, and that is the multiplication property of equality. All right, so let's talk about the property itself. It's kind of easiest just to tell you how it works. All right, so if we have the equation negative 4 times x equals 16, so I'm going to rewrite that just so it's a little bit bigger. So here's my equation. Notice that this time the x is being multiplied by negative 4. So in order to get rid of multiplication, we will need to do division. Okay, just like when in the last section we were doing adding, we would use subtracting. So same thing here. We have division, the x is being multiplied by x, so to get the x isolated, we have to divide by negative 4. Now, if you're dividing by negative 4 on the left, you must also divide by negative 4 on the right. So here the negative 4's will divide out, leaving us 1x, and on the right, 16 divided by negative 4 is negative 4. As always, when you are done, please make sure you check your answer. All right, so negative 4 times x, and our x we think is negative 4. Does that equal positive 16? Yes, it does, so we're good, and that is the correct answer. So the multiplication property of equality just says that if you multiply or divide the left by a number, you must also multiply or divide the right by that same number. All right, if you have fractions, you have to think back to everything we did back in section 1.3. When we have, right here we have x being multiplied by 1/7. So to get rid of 1/7, we would divide by 1/7. But back in section 1, we learned that dividing by 1/7 is the same as multiplying by its reciprocal. So if you have a fraction that is multiplied by x, you're going to multiply both sides by the reciprocal. Right, so over here, the 7's will divide out, the 1's will divide out, right? All we have left is the x. On the right, multiplying these fractions, we notice 5 and 7 are both primes, and neither of those go into 9. So we're just going to multiply across 35/9. All right, so you're going to have to remember all those skills that we learned with fractions. All right, and as always, please make sure you check your answer at the end. All right, so 1/7 times x equals 5/9, and we think x is 35/9. All right, so if we look, 7 does go into 35, right? That goes in there 5 times. So 5 times 1 is 5, and all we have left is 9 in the denominator. So we are good, and there is our answer. So again, make sure that you're always checking your answer when you are done. All right, so if you want to try one, feel free. All right, so let's see if your work matches mine. So we are multiplying a by 3/5. So to get rid of that, we are going to multiply by the reciprocal, multiply by 5/3. So I must also multiply the right by 5/3. So here the 3's will divide out, the 5's will divide out, and I'm left with a. Over here, I'm going to change that into a fraction. So 3 does go into 12, right? 12 is 4 times 3, so that the 3's would divide out, and I would just be left with 4. So I have 20 over 1. And 20 divided by 1 is just 20. Again, make sure you check. If you're really good with your calculator, you can actually just plug that into your calculator. There is a fraction button on most calculators, so again, that's just you getting to know your calculator. So if you would like to just use your calculator to do the checks for you, that's fine. 3/5 times 20, press enter, you should get 12, okay? So you definitely take advantage of that calculator to do the check for you. Definitely make things go a little bit faster. This also works for decimals. Again, x is being multiplied by negative 1.2, so to get rid of multiplication, we have to divide. So the negative 1.2's will divide out, and we'll be left with x. And then again, feel free to use that calculator. If you get really stuck with decimals, I understand a lot of you struggle with decimals. So negative 36 divided by negative 1.2 should be positive 30 when you put that in your calculator. And again, just make sure you check. So negative 1.2 times 30, put that in your calculator, you should get negative 36. So that works out. And then I put a box around my answer after I have checked it. So the multiplication property of equality is pretty straightforward. It's always going to be the last thing you do when you're solving. That's the good news. So this is the last property that you'll use. After you have done this, they're going to put both of these properties together in this section. So now you're really going to get to practice everything that we have talked about in sections 1 and 2 and now in section 3. And this is where there is a checklist in your book, and I really try to stick to that checklist. So just like we talked about in section 1, we're going to simplify both sides. So if you look at the left-hand side, we do have like terms that we can put together. 4x minus 8x is negative 4x. Then I go to the right. Can I simplify the right? There's nothing I can do, so that's 16. So make sure that you simplify both sides individually before you ever get started. And then I see, in order to get the x by itself, I have to divide by that negative 4. So I'm going to divide both sides by negative 4, so I get the x by itself, and 16 divided by 4 is negative 4. So as these problems get more complicated, the check is going to be even more important. So 4 times, so again, I'm going to do my skeleton first. Inside the parentheses, I'm going to put a negative 4. And then again, if you want to type this in your calculator exactly as it appears and press enter, you should get 16. So if you want to use the calculator at this point, it's really helpful. Just write it down so that you know exactly what to put in your calculator, and then use that calculator to do the check. All right, 3z minus 1 equals 26. So left-hand side, there's nothing we can simplify. Right-hand side, also nothing we can simplify. So this one is in simplified form. So notice the z is being multiplied by 3, and then we are subtracting 1. So the first thing we have to do is we have to get this term that has the z completely isolated, which means we have to get rid of subtracting 1, which means we must add 1 to both sides. And we call that isolating the variable term. So I've isolated the term first that contains the variable. Once you've isolated that variable term, then you can focus on isolating the variable itself. So I can divide both sides by 3 to get that z by itself. And then again, just make sure you go back and check. In the interest of time, I'm not going to do it every single time. So make sure that you check, and you should find out that 9 times 3 is 27. 27 minus 1 is 26. You may even just do the check like that if it's simple. You can just plug it in and do it in your head. All right, another example. So first, again, go to the left-hand side, simplify anything you can. I do see some like terms. So I've got like terms here. 12x plus 8x is 20x. 30 minus 6 is 24. Then I go to the right-hand side, nothing I can do with 10. Okay, so there's the simplified version of my equation. Simplified the left and simplified the right. Again, I have to get the variable term by itself first, so I got to get rid of this adding 24, which means I'm going to subtract 24 from both sides. So 20x equals 10 minus 24 is negative 14. And then I can isolate the x, which means I have to divide by 20. So I'm going to divide this side by 20 as well. Negative 14 over 20, I can simplify that. Both of those have a factor of 2. So this is negative 7 times 2, and this is 10 times 2. The 2's will divide out, and I'm left with negative 7/10. So again, this is another great place where that using your calculator is going to come in really handy with your check. So I'd start with putting my skeleton together. There's my skeleton. Inside the parentheses, I'm going to put negative 7/10, negative 7/10. And then I'm going to put this entire left-hand side of my calculator. And you have to put it in exactly as it appears right there with the parentheses and everything. And when you press enter, it should give you 10. So then I know that that is the correct answer. So always make sure you're doing that check at the end. I cannot stress that enough. All right, last example. So if you want to try this on your own first, feel free to pause. All right, let's see if your work and my work match. So 5x times 2x is 10x. 5x plus 3 is 15. Times 3 is 15. Okay, so there's my left-hand side, simplified as much as I can. Right-hand side, negative 1 plus 7 is 6. So there is my simplified equation, simplified both sides. Again, I have to get this 10x by itself, which means I must subtract this 15 first. So I get 10x equals 6 minus 15 is negative 9. And then to get the x completely by itself, I have to divide both sides by 10. So there is my final answer, -9/10. Again, please do the check. I cannot stress this enough. Always check. And when you check, you will find out that that is indeed the correct answer. All right, so now that you know the only two tools that we need, go ahead and practice that 2.3 homework. When you come back, we're going to do section 2.4, which is just kind of all different sorts of equations that you could encounter. I have a checklist for you. So we're not going to learn anything new in section 2.4. It's just going to be some more complex examples of these equations. All right, I'll see you then.